RAM architecture. How memory modules process data. 1. Introduction. A high-resolution, cinematic 3D render of a RAM module slotted into a motherboard, pulsing with data streams. Still video. Asterisk logo appears in a minimalist, clean style. Speed is the heartbeat of computing, but what truly happens when data enters your memory? Welcome to Asterisk Still Video. Today, we disassemble the architecture of RAM to see how memory modules process data in real time. 2. The core mechanism. A microscopic, stylized view of a DRAM cell grid, capacitors and transistors flickering. At the atomic level, RAM is a massive grid of capacitors and transistors. Each tiny capacitor holds a single bit of information. A charge is a 1 foot, no charge is a 0. To process data, the controller must constantly refresh these capacitors as they lose their charge in milliseconds. 3. The command flow. A visual flowchart illustrating the interaction between the CPU, the memory controller, and the RAM sticks. The CPU doesn't talk to the RAM directly, it speaks to the memory controller. When a request is made, the controller sends an address to the RAM. The row and column strobe signals, RAS and CAS, act as the coordinates to pinpoint the exact location of your data within the matrix. 4. Throughput and latency. A split-screen comparison. One side shows high-frequency data throughput, the other shows low-latency command cycles. Why does frequency matter? Higher MHZ means more clock cycles per second, increasing raw bandwidth. But latency? That's the delay between the request and the response. True performance is the equilibrium between these two forces. 5. Conclusion. The motherboard assembly zooms out to show a fully functional, glowing system. The asterisk still video, asterisk subscribe button appears on a clean, empty canvas. Memory is more than just capacity. It is the bridge between storage and calculation. Mastering this architecture gives you control over your system's efficiency. Subscribe to Asterisk Still Video for more technical deep dives into the hardware that powers your world.